Acylation means you need something which is having a COCH3 group. It is an antiseptic. Chloroform is an anesthetic. This is an antiseptic. Now what is electrophile, which is having attraction towards an negatively charged species? So it itself will be positively charged. Halogenation means we are going to add halogen, right? Or we are going to substitute what? Halogen. Hello everyone, this is Amli Unikrishnan from the Department of Chemistry. So today I am back with session 6 of the chapter Haloalkanes and Haloarenes. So in the last session we discussed elimination reactions, that is beta elimination reaction, as well as a reaction with metals and as well as the reactions of haloarenes. We started with substitution nucleophilic reaction, right? What is the reason why it shows lesser reactivity towards substitution nucleophilic reaction, as well as few substitution nucleophilic reactions were discussed in the last session. So in today's session we are going to study about the further reactions of haloarenes, that is electrophilic substitution reaction, reaction with metals in case of haloarenes, and after that we are going to move to the last topic, that is polyhalogen compounds. Okay, so let's begin with electrophilic substitution reaction. So we have already studied nucleophilic substitution reaction, that means nucleophile will be substituted in place of halogen. So what will be electrophilic substitution? In place of halogen, an electrophile will be substituted. Now what is electrophile, which is having attraction towards an negatively charged species? So it itself will be positively charged, right? Okay, so halo group is electron withdrawing group, yet it is ortho-para directing in electrophile substitution reaction due to resonance. Okay, so what does that mean? In haloarene, because of resonance we have, so as you can see here, the lone pair of electrons will be shifted here. You will have a double bond here. This bond will become a charge. Now this charge will become a bond and this bond becomes a charge, which is shown here. Now this charge will become a bond and this bond becomes a charge, which is shown here. So as you can see, the negative charges will be present in the ortho as well as the para position. This is one ortho position, another ortho position. This is the para position, right? So due to the minus I effect of halo group, ring gets a little deactivated. So halo group, as it is electron withdrawing, it is having a minus I effect. So what happens? It makes the ring a little deactivated. As a result, electrophilic substitution is slow and requires more drastic condition. So it will just not happen just by that. We need to improve the conditions so that the electrophilic substitution reaction happens because of the minus I effect of the halogen group. Okay, we are discussing haloarenes, right? So because of the minus I effect of haloarenes, the halogen groups, that is why it shows less reactivity. Now, the first reaction is halogenation. So, from the name itself, we can understand halogenation means we are going to add halogen, right? Or we are going to substitute what? Halogen. Okay. So, when chlorobenzene is heated with chlorine in the presence of anhydrous aluminum chloride, a mixture of ortho and para dichlorobenzene is obtained. So, we have already taken a chlorobenzene here, right? To which we are adding chlorine. Okay, to which we are adding chlorine. So, generally we can mention it as halogenation. So, it can be also called as chlorination if you are adding chlorine, bromination if you are adding bromine, right? So, when we are adding chlorine in presence of anhydrous aluminum chloride, what happens? This Cl2 we are adding, right? So, either it can be substituted in the ortho position, it can be here or here, right? Or else it can be substituted in the para position, not in the same compound. It will be present as two different products. So you will get a para product as well as an ortho product. So 1, 2, 3, 4. So this is 1,4 dichlorobenzene and this is 1,2 dichlorobenzene. 1,2 dichlorobenzene. So the para will be always the major product because it is more symmetric. As you can see, one is on the top, one is on the bottom, like they are para position to each other. So it will be more stable. So that is why it is major product. So it is simple. You have to add the chlorine or substitute the chlorine in the para as well as the ortho position. Next one is nitration. So from here itself you can tell me what is nitration. We are going to add a nitro group, okay, in the ortho and para position. So when chlorobenzene is heated with a mixture of concentrated nitric acid and concentrated H2SO4, a mixture of ortho and para chloronitrobenzene is obtained. So this mixture of concentrated H2SO4 and concentrated HNO3, nitric acid and sulfuric acid in concentrated, this is called as the nitrating mixture. This is called as the nitrating mixture, which helps in nitration, right? Nitrating mixture helps in nitration. So what happens? The nitro group will be either attached in the para ortho position and para position. You will get two products. Again, the para product will be the major product, right? Moving on to the next one, that is sulfonation. We are going to add a SO3H group here. So when chlorobenzene is heated with concentrated sulfuric acid, a mixture of ortho and para chlorobenzene sulfonic acid is formed. Okay, so concentrated sulfuric acid is what we are using here. So if we are heating it, what happens? Either in the ortho position or the para position, the SO3H group will be attached. So this is the 1, 2. If we number it like this, it is 2-chlorobenzene sulfonic acid. So this much part is called as the sulfonic acid, benzene sulfonic acid, to which on the second carbon atom you have a chloro group. Now this is 1, 2, 3, 4. So this will be 4-chlorobenzene sulfonic acid, right? So this much is called as benzene sulfonic acid, to which on the second position and the fourth position you have chlorine. Okay, so this is sulfonation. So I hope it is clear. In case of halogenation, we are going to add the halogen in presence of anhydrous aluminum chloride. In case of nitration, we are going to add concentrated nitric acid and sulfuric acid, in which nitro group will be substituted in the ortho and para position. The next one is sulfonation, wherein it will be substituted in the ortho and para position. Now the next one is Friedel-Crafts reaction. In Friedel-Crafts reaction, you have two types. One is Friedel-Crafts alkylation, Friedel-Crafts acylation. Even this you have studied in class 11, right? So the first one is Friedel-Crafts alkylation. Now what does alkylation means? From the word itself you can see alkyl. We are going to add alkyl group, right? Alkyl group will be substituted. So when chlorobenzene is heated with methyl chloride. What is methyl chloride? CH3Cl. So in the CH3Cl, this CH3 is your methyl group, which is the alkyl, right? In the presence of anhydrous aluminum chloride catalyst, as a mixture of ortho and para chlorotoluene is formed. Okay, so this is chlorobenzene, to which we are adding any alkyl chloride, not necessarily methyl chloride. I have taken the example CH3Cl. It can be C2H5Cl. It can be C3H7Cl, any alkyl chloride. Okay, here I have taken methyl chloride in presence of anhydrous aluminum chloride. So this chlorine is already there. Now what will be substituted? This methyl group will be substituted in the ortho as well as para position. Okay, so you are going to get 1-chloro-2-methyl benzene, or else you can also call this much part as toluene, right? Yes, and this is 1, 2. 2-chlorotoluene, or else you can call also call it as 4-chlorotoluene, right? Because in benzene, where you have the methyl group, it is called as toluene. So it can be 4-chlorotoluene also. So of course, again the para product will be the major product. So this is Friedel-Crafts alkylation, where you are going to add an alkyl group. So for that you of course need an alkyl halide, right? Okay. Now the next one is Friedel-Crafts acylation, for which you need an acyl group. Now what is acyl group? COCH3. This is what we are going to substitute. So if this is what you are going to substitute, of course some RCOCH3 we have to use, right? Okay. So when chlorobenzene is heated with acetyl chloride in the presence of anhydrous aluminum chloride catalyst, a mixture of ortho and para chloroacetophenone is formed. Okay. So as you can see here, chlorobenzene we have taken. This is CH3COCl. So this R which I have mentioned here, it is CH3COCl. Okay, so this CH3COCl we have taken here. Now to this anhydrous, in presence of anhydrous aluminum chloride, what is going to happen? Either the COCH3 will be substituted in the para ortho position and the para position. So again two products will be formed. So of course the para one will be the major product. So in all these reactions which we have discussed till now, it's only what you have to remember is the electrophile will be substituted in the ortho and the para position. So you just have to remember in detail what is the reagent that we are using for alkylation, for acylation. What is the reagent that we are using? According to that, easily you can substitute it in the ortho and para position, and you will get to know that the para is the major product. That's it. So here it is acylation means you need something which is having a COCH3 group, right? So we are going to add an acetyl chloride here. Okay, it can be any acetyl halide. Okay, so this is Friedel-Crafts acylation. Now the next one is reaction with metals. Okay, so till here we were discussing about electrophilic substitution reaction, that is sulfonation, nitration, chlorination, Friedel-Crafts alkylation, Friedel-Crafts acylation. Next one is reaction with metals. We have studied the same thing in haloalkanes also, where we studied Wood's reaction, right? As well as formation of Grignard reagent, that is alkyl magnesium chloride. Here we are going to study Wurtz-Fittig reaction. So Wurtz reaction we have already studied. So based on that itself, easily we can understand Wurtz-Fittig also. When a mixture of alkyl halide and aryl halide is heated with sodium in presence of dry ether, alkyl benzene is formed. That is haloarene is formed. So in case of Wurtz reaction, just Wurtz reaction, what did we used? Alkyl halide was only used. Right, 2 alkyl halides were used, 2 moles of sodium was used. So what will we get? That alkyl parts will combine together and you will get an alkane. But in this case, you need an arene, right? So in that case, you are going to use one haloarene. One will be haloarene, one will be haloalkane. That is why you can see Wurtz-Fittig. So in that way, remember 2 different names are there, Wurtz and Fittig. That means one will be haloarene, one will be haloalkane. Now what will happen? Again, the X from this one, that is halogen from this one, 2 moles of sodium and the halogen one from this one will be removed. Okay. So I'll just draw it here. So this is the haloarene, to which 2 moles of sodium we are taking, and we have the haloalkane. Now what happens? This much part will be removed. Now what is left behind? Only the benzene and the alkyl group, right? So what happens? On the benzene ring, you will get the alkyl group, right? So on the benzene, you will get the alkyl group and sodium halide will be removed, okay? So one example is just shown here. Bromobenzene we have taken and 2 moles of sodium, and methyl bromide is also taken. So what happens? This bromine and this bromine, that is this much part will be removed. The methyl will be directly attached to the benzene ring, where you will get toluene and sodium bromide, okay? So this is similar to Wurtz reaction itself, but in Wurtz reaction, both the compounds we are taking is haloalkane itself. In here we are taking one haloalkane and one haloarene, so that the benzene and the alkyl group will combine and form the compound. Clear? Now the next one is Fittig reaction. Now Wurtz reaction we have studied, Wurtz-Fittig reaction studied. Now what is in Fittig reaction? Both we are going to use haloarene itself, okay? When aryl halides are heated with sodium in presence of dry ether, 2 aryl groups join together to form biphenyl, okay? So instead of taking, here you saw one haloarene was taken, one haloalkane was taken. In Fittig reaction, we are only going to take haloarene. In Wurtz reaction, only haloalkane, right? In Fittig reaction, only haloarene. So 2 moles of haloarene in presence of sodium and dry ether. What is going to happen? As you can see, this is one haloarene, 2 moles of sodium, another haloarene. Now what happens? This much will be removed, that is 2Na and 2X. Now what will happen? These two will combine together and form a structure like this. These two will combine. So this is called as biphenyl. 2 phenyl groups are there, one phenyl group, another phenyl group, which will give you biphenyl. I hope it is clear. Now moving on to the last part of this chapter, that is polyhalogen compounds. So poly means what? Many, right? And halogen, of course, halogen. So polyhalogen compounds means it is having more than 2 halogen atom containing compounds, okay? So the first one we are going to study is dichloromethane. Dichloromethane, it is having 2 chloro atoms, right? 2 chlorine atoms. So it is CH2Cl2. That is from methane. If we are substituting it by 1 chlorine atom, you will get CH3Cl. Then one more, if you are replacing, you get CH2Cl2, right? So that is CH2Cl2, which is called as dichloromethane. Right. So what we are going to study is here the uses and the importance of each of these polyhalogen compounds, right? So it is used in solvent in drug industry and paint remover and propellant in aerosols and as a cleaning agent for metals. So you have to study 1 or 2 uses of this as well as its environmental impacts. So it's an easy part, but you have to remember what are the important points from these, okay? Now the environmental impact, its direct contact to our skin develops redness and burning sensation. It causes problems to your skin, right? When you come in contact, your skin come in contact with it, causes redness and irritation, right? It is harmful to our central nervous system. Its high level in air causes nausea, numbness in finger and toes, okay? So it generally causes an irritation and also extremely, if it is if we come in contact, it can be a problem to our central nervous system, right? The next one is trichloromethane, which is chloroform. This is a very, very familiar word to you, chloroform, which is used as an anesthetic, right? Okay, so chloroform, now you know what is the formula for chloroform. It is CHCl3, okay? Trichloromethane. So here you can see, if one more hydrogen is being replaced, you get CHCl3. So this is your chloroform, right? So chloroform is a sweet smelling liquid boiling point around 334 Kelvin, non-inflammable, but its vapor causes unconsciousness. Okay, unconsciousness, you know that when chloroform you might have seen in movies also. When you keep chloroform to your face, what happens towards your nose? If you inhale it, you will get unconscious, right? So it is used as an anesthetic. Actually, it is used as an anesthetic before, but nowadays it is not used as an anesthetic because of some reason that we are going to discuss now. So when exposed to sunlight and air, it slowly decomposes into phosgene. It forms a poisonous gas which is called as phosgene, which is COCl2. This is very, very important to remember. It's called as phosgene, a poisonous gas. It is therefore stored in closed dark bottles, completely filled so that air is kept out. Okay, so usually you will find chloroform in dark brown colored bottles, and it will be kept inside in the shells which is away from the sunlight, because once it comes into contact with the sunlight, it forms a poisonous gas which is called as phosgene, which is harmful. That is the same reason why it is not used as an anesthetic in our body, because it will form this poisonous gas in our body which will cause certain cases death as well. So that is why chloroform is not used as an anesthetic in the hospitals, right? So chloroform, in the presence of sunlight and oxygen, it forms phosgene, COCl2 and HCl. So that is why it is not used. It is used as solvent for fats, oils, varnishes, waxes, etc. for the preparation of chloroetone, which is a drug, and chloropicrin. These are drugs which are very important as an anesthetic after being mixed with ether. Okay, it's used as an anesthetic after it is being mixed with ether. Okay, next one is in the manufacture of freons, that is refrigerants. In that also it is being used. The next, environmental impacts of it. On inhalation, it depresses the central nervous system and causes headache and dizziness. Of course, it is causing unconsciousness, means it causes dizziness, right? Now the next one is chronic exposure damages liver and kidneys. On exposure to sunlight and air, it slowly decomposes to phosgene. That is a harmful effect that we just discussed now. And ethanol 1% is added to retard the oxidation of phosgene into harmless ethyl carbonate. Okay, so the next one is triiodomethane. Chloroform was trichloromethane. Now triiodomethane or iodoform. Okay, so it is a yellow crystalline solid, pungent characteristic odor, melting point is 392 Kelvin, and it is steam volatile. It is used as antiseptic. It is an antiseptic. Chloroform is an anesthetic. This is an antiseptic. Okay, it is used as an antiseptic for dressing of wounds in the manufacture of certain pharmaceutical products as well. Environmental impacts: when it comes in contact with skin, iodine is liberated. And for antiseptic properties it is used, and it has a very objectionable smell, a very irritating smell also it is having. Okay, so this is about triiodomethane or iodoform. Next one is tetrachloromethane, CCl4. This you might have used in your lab also for your salt analysis. Tetrachloromethane, CCl4. It is a liquid, boiling point around 350 Kelvin, non-flammable, hence used as a solvent for fats, oils and waxes, etc. It's used as fire extinguisher under the name pyrene. Okay, it's used as a fire extinguisher. It's as a solvent also in the dry cleaning it is used. In medicine as a helminthic for the elimination of hookworm. Now what is the environmental impacts? Its vapors when breathed causes nausea, dizziness, vomiting, etc. and causes damage to nerve cells permanently. So its inhalation is a problem. On exposure, it causes cancer, irregular heartbeat, and person may go to coma. So it has a tendency to cause cancer as well. Now its vapor depletes ozone layer. Ozone hole permits the ultraviolet radiation to reach on earth and may cause skin cancer, eye disease and disorder. It may adversely affect our immune system. So these are some disadvantages of tetrachloromethane. Okay, the next one is freon, CFCs. While discussing about chloroform also, we were discussing chloroform is used in the preparation of freons, which is refrigerants. Okay, so freons are small organic compounds containing carbon, chlorine and fluoride. Okay, that stands for CFCs. Okay, carbon, chlorine and fluoride. The most Common freons are CF2Cl Freon 12 and CF3Cl, which is Freon 11. So it is used in air conditioning and domestic refrigerants for cooling purpose. So freons are generally used as refrigerants. The next one is as propellants in aerosol and foams to spray out deodorants, cleaners and insecticide. Halothane CF3CHBrCl is used as inhalation anesthetic. Okay, so all these are uses of CFCs. The next one is environmental impacts. Most freons eventually makes its way into the atmosphere where it diffuses unchanged into the stratosphere. In stratosphere, freon is able to initiate radical chain reaction that can upset the natural ozone layer surrounding Earth. So it causes ozone layer depletion because it remains in the stratosphere. So that is a disadvantage of freons, and it is having a use in as it is used in the refrigerants of a refrigerator as well as in AC, right? Next one is P-P dichloro diphenyl trichloroethane, that is DDT, dichloro diphenyl trichloroethane. Okay, dichloro diphenyl trichloroethane is called as DDT. That P and P dash stands for para position. So uses as an effective insecticide. DDT is used as an insecticide for mosquitoes, flies and crop pests, and it is anti-malarial. Okay, it is anti-malarial as well as it is used as an insecticide. Okay, environmental impacts. DDT is the first chlorinated organic insecticide. So it is stable and fat solubility is a great problem. So as it is stable and it is difficult to get soluble, what happens? It remains in the soil and causes problems with the fertility of the soil. It is prepared from chloral and chlorobenzene in the presence of concentrated sulfuric acid. So this is the structure of DDT, dichloro diphenyl trichloroethane. Okay, so this polyhalogen compounds that we have discussed, that is chloroform, iodoform, dichloromethane, trichloromethane, as well as the DDT and freons as well as CCl4. All these are very important to study. It is easy to remember. You just have to remember few uses as well as the important parts of it. Right? In case of chloroform, it is very important to remember about phosgene. Such points you have to remember. So by this, we come to an end to this chapter, haloalkanes and haloarenes. So I hope the concepts that I've covered in this chapter is clear for you. So that's all for today. Thank you.